Impact of pooling on waiting time. Consider two processes, each with one server and its own demand, and assume the servers and demands are identical. So this is what we have represented in this picture. The two servers here, one for one process, the other for the other process, are identical servers, and we assume the inflow of customers is identical in terms of statistical parameters. So for each, we will assume that time between arrivals is on average 4 minutes, service time is on average 3 minutes, and coefficients of variations are equal to 1. And now we want to ask ourselves, would pooling those two resources, I mean, making this one process with two identical resources that work in parallel, and then combining the demands, right, those two demand flows into one, would it help reduce waiting time or not? So to evaluate it, I will use a simple Excel spreadsheet that you can easily create, where you have the parameters of the queuing model or waiting line model inserted here. We will actually change them accordingly. And then we have a calculation of utilization. Remember, the utilization must be no more than 1 for the model to work. Actually, it must be less than 1. Then we have the utilization factor, which is U to the certain power that depends on M, and then divided by 1 minus U, utilization. And the variability factor that takes the coefficients of variation, squares them, adds them, and divides them by 2. Right? And then we have the TQ formula, which is basically taking P over M, multiplies this by utilization factor and then by the variability factor. So this is a solution for an earlier example. So in this case, I said I have processes, two identical processes, each with one server. So number of servers will be 1. Time between arrivals is here. It was 4 minutes, and time for service on average was 3 minutes. And in addition to this, I need to say that coefficient of variation for CVA is CVP, both of them are 1. So if you do the calculations, you'll find out that the waiting time on average is 9. What's the unit? Well, the same unit as I used for 3 and 4 must be 9 minutes. So if I have a single server in my example, each of those single servers will have 9 minutes of waiting time. Independent resources, TQ is 9 minutes. What about the pooled resource? So I need to change here now. The number of resources will be 2, but what also changes is the time between arrivals. Before, the time between arrivals was 4 minutes, right? And so I had one customer arriving every 4 minutes. But if I'm pulling the resources together, I have two of the demand streams joined together. So I will in fact have two customers arriving every 4 minutes, one from one process, the other from the other process. Remember, this is the analysis on average. If I have two customers arriving every 4 minutes, that's like one customer arriving every 2 minutes. So the inter-arrival time A has to be changed to 2. Right? And this is actually everything we need to change. The average processing time is still 3 minutes, but there are now 2 servers. And so you will see that the average waiting time drops significantly. It was 9 minutes. It is just a little bit less than 4 minutes, right? 3.95 minutes. So going back to my slide, I can say for pooled resources, for this second picture here, the average waiting time is 3.95 minutes. So what I want you to see is we didn't change anything in the capacity. The servers are still the same. There could be minimal or no investment here, turning this into this, right? All we did is we pooled both resources together to serve the demand joint. The same demand is being served, and somehow, on average, the waiting time is significantly reduced. Why is it reduced? It's very easy to see, right? Because if you think about the independent resources, right, they might have sometimes customers waiting and sometimes they might be idle. And the thing is that it might be that this resource is idle while the other one has waiting customers, right? And in this case, when they are independent, those customers do not know that they could go right? Or do not have an opportunity even to go to another server. They are stuck with this server, right? So when one resource is idle and the other is overloaded, right, has customers waiting, this creates additional waiting time when the resources are independent. For such a case, right, at least the servers, both servers would be working, and so the average waiting time would drop. So we might say, right, that pooling resources decreases waiting or average waiting time, and so there is an advantage. There are kind of economies of scale also in the waiting time problems. Notice that, in fact, the pooling doesn't change the utilization. In both cases, in the separate systems, the utilization was 75%. It was 3 minutes over 4 minutes, right? 75% when they were independent. And in this case, it is still 75% because it is 3 minutes over m times a, and m is 2 servers times a changes to 2 minutes, so it still is 4 in the denominator. It still will be 75%. So to summarize what we said in this example of pulling two servers into one process, or two processes into one process, pooling can serve the same number of customers using the same service time and the same utilization with much less waiting time. So of course we can use it in order to reduce the average waiting time. Right, and this chart shows you if you go from one server, keeping the utilization constant, for example, at 80%, if you go to two servers, pulling two demand streams, and joining the two identical servers, the average waiting time drops, right? And if you pull 5 servers or 10 servers, there is still a decrease, but of course the decrease becomes smaller and smaller as you add servers, right? So the pooling is especially useful initially. So, right, so the first benefit you can reduce waiting time without extra servers, or you can actually reduce number of servers, keeping the same waiting time. It's going to be harder to see on this graph, but let's say if you had 5 servers and you would be serving a certain demand streams with two systems, each with 5 servers, if you pull them together, you could, of course, operate with 10 servers and have shorter waiting time, but perhaps you could operate with 9 or 8 servers and have the same waiting time as you had originally in the independent systems with 5 servers each. So you can actually reduce the number of servers. Generally, this is a kind of economy of scale which you see, and this is, of course, what creates advantage. One more advantage for, let's say, companies like large supermarkets over small markets, small shops, grocery stores that operate, let's say, locally near the customers. Right? Not only they might have higher cost of rent, not only the small shops might have lower inventory turns because they are small scale, so they cannot move products as fast as the large supermarkets, but also they will have a disadvantage, right? If you think about, let's say, a supermarket operates with 5 cashiers or 10 cashiers, they can operate with 95% utilization, right? And very low waiting time. And if you want a similar waiting time for one cashier, you have to drop utilization to something like 60%, right? So if not, then the customers, right? If there's more customers, the customers will wait a lot. And maybe some of them will say, I don't like this shop. There's too much waiting. I will go somewhere else. So you might lose customers. Your utilization will drop to 60 or 50%. And that will mean also that your cost of labor, direct cost of labor per customer will be effectively higher. And so you will have a disadvantage when competing with a large supermarket. Of course, there are advantages, right? A small store can be closer to customers, so they might be able to at least get something much faster without wasting a lot of time to go further to a large supermarket. But of course, that's why people actually sometimes are willing to pay higher prices for products in order to get this convenience. Is pooling a panacea? Is this a solution for all our problems? Let's pool everything together. It brings only benefits. Not really. There are actually some situations where there are no benefits, or even it can hurt your system. So one example is when the pooled systems are not truly independent, it doesn't make sense to pool them. If you consider a supermarket, actually a supermarket was not exactly what we saw in our example. It wasn't a system with multiple servers and one waiting line, right? A supermarket looks more like this, right? Every cashier has a separate waiting line, and this is multiplied by, not just two, but some larger number of, right, cashiers. So should we pull it and create one waiting line for all cashiers? It is sometimes done in supermarkets, but the main benefit it achieves is that customers are actually served first come, first served when you do this, right? Because in this system, if you're not lucky, you might have a longer waiting time, even though you arrived earlier than another customer who comes later and is lucky that this server somehow works faster, right? At least for some customers. In this case, there is more fairness. But in fact, these systems are not truly independent, because if you are in a supermarket and you're standing in one line and you see another line is empty and the server is idle, then of course you're going to jump here immediately and reduce your waiting time. So these systems in supermarket cashiers, they work more like one waiting line, except that the first come, first serve rule is not really satisfied in every case. Also, pooling typically requires servers with broader range of skills. So example would be if you have a large call center where you operate services for many types of companies. And suppose you're operating some services for computer selling company or software, and another for sports shoes. With problems with sports shoes, people can call the typical answers on how to solve problems. If you train your workers to answer, you can easily train them to answer questions about one type of product, but training them for many types of products may actually be very difficult, might cost you much more, and so pooling will not have as much benefit here. Maybe even learning curve, people who only specialize in answering one type of questions might get much better very quickly in those questions. If you ask them to learn all about possible problems with multiple types of products, then they will not. Their service time might actually increase, and therefore the system might not actually be improved. In many service environments, also customers value being treated consistently. For example, in legal services, right? If you have a customer calling with a legal question, they probably want to talk to the same lawyer every time, the one that they trust, and so pulling multiple lawyers to answer, questions of any customer, right, is not probably not a good idea. Pooling also can introduce additional setups. Again, legal services would be a good example, because right, if you call a lawyer and then your lawyer is not available and you have to talk to another one, maybe you need to explain additional details, or the lawyer has to find out about your situation, learn about your situation first in order to advise you better. So this would be an increased service time, right? It wouldn't really help. It wouldn't really help to have pooling in legal services. And also, pooling can backfire if you pool different customer classes. An example would be, let's say, if you have different banking services, regular customers and maybe some premium customers, large value customers, right? The regular customers in a bank, perhaps they have to wait 10, 20 minutes on average. And then, let's say the premium customers might be provided a service with average waiting time of 10 seconds. Right? If you pull together those two streams, then of course average waiting time for the regular customers will be significantly decreased, but the premium customers might not like the new situation, and therefore they might actually maybe shift to another bank because they will not accept a half a minute or 1 minute waiting time when they could have a system where they don't wait almost at all. So sometimes this can backfire. Also, if you think about the same customers, if you combine like cashier services with account opening services, for example. Opening an account takes much longer time, and cashier services, paying a check or doing something like simple things, right? These have different processing times. Yes, pooling will decrease average waiting time, but in fact, when you want to complete a very short service, you're less willing to accept longer waiting time. When you open an account and you know it will take you 1 hour, you're more likely to accept a 20-minute waiting time for that.